Welcome to the DIY Honda Garage channel. The DTC code P0113 indicates an issue with the intake air temperature IAT sensor 1 circuit, which has detected a high voltage condition. This diagnostic trouble code is primarily linked to the IAT sensor's output voltage exceeding a specified limit, prompting the Powertrain Control Module, PCM, to classify it as abnormal. The IAT sensor plays a crucial role in providing the engine control unit with real-time data regarding the temperature of the incoming air, which is essential for optimal engine performance. Its location is typically near the mass airflow MAF sensor in the air intake system. The PCM, which is responsible for various engine management functions, utilizes this data to adjust fuel mixture and timing for better efficiency and emissions control. Therefore, understanding the implications of this DTC is vital for effectively diagnosing and rectifying engine performance issues. The IAT Sensor 1, crucial for measuring air temperature, is generally located in the intake manifold or close to the MAF sensor. This sensor sends temperature readings to the PCM to facilitate accurate fuel-air mixture calculations. The high voltage condition detected across this sensor may compromise the vehicle's engine efficiency, leading to potential operational issues. The PCM interprets the data from the IAT sensor to make necessary adjustments for optimal combustion. If the IAT sensor experiences failure or abnormal voltage readings, the engine may run rich or lean, adversely affecting performance and fuel economy. Hence, proper sensor function is essential for maintaining vehicle efficiency and compliance with emission standards. The potential causes of the P0113 code include a faulty IAT sensor 1, which may send incorrect voltage signals to the PCM. Additionally, an open circuit in the wiring associated with the IAT sensor could also result in high voltage readings. This can occur due to damaged or corroded connections that affect sensor performance. Another possibility is a malfunctioning PCM itself, which could incorrectly interpret valid signals from the IAT sensor, leading to erroneous voltage readings. It is vital to systematically evaluate each potential cause, starting from the sensor down to the PCM and wiring components to diagnose the root of the issue efficiently. When the DTC P0113 is triggered, the most immediate symptom is the illumination of the check engine light, CEL, on the dashboard. This warning serves as an initial indicator that there is a fault in the engine management system. Additionally, drivers may experience rough engine performance, which can manifest as hesitations or stalling under load. Another common symptom is poor fuel economy, as the engine fails to calculate the ideal air-fuel mixture. The engine may run too rich or lean, directly impacting overall efficiency. Over time, the accumulated stress on engine components due to incorrect readings can lead to more severe mechanical issues if left unaddressed. The first troubleshooting step involves turning the vehicle ignition to the on position without starting the engine. This action enables the onboard diagnostic system and allows for real-time monitoring of the IAT Sensor 1's voltage through the Honda Diagnostic System, HDS. Once the system is active, the technician must assess the IAT sensor voltage reading displayed on the HDS. A reading exceeding 4.92 V indicates that the issue has duplicated, corroborating the presence of a high voltage condition within the sensor circuit. It's crucial during this step to ensure that any external factors do not interfere with the readings, providing a clear picture of the sensor's performance. In this step, the technician must disconnect the MAF sensor/IAT sensor 1 connector, 4P, to isolate the sensor from the circuit. Following this disconnection, a jumper wire is used to connect terminals number 2 and number 4 of the connector. This action simulates the normal circuit condition and allows for a voltage inspection without interference from external components. After making the jumper connections, the vehicle should return to the on mode to check the HDS reading again, specifically for IAT sensor 1 voltage. An expected voltage of less than 4.92 V confirms that the sensor itself is malfunctioning, while an abnormal reading indicates issues elsewhere in the system, advocating for a systematic follow-up on connected components. This step focuses on examining the wiring connected to ITA1 and SG2. Initially, the technician should ensure the MAF IAT connector and the PCM connector B101P are disconnected to prevent any electrical shorts during testing. The wiring inspection should verify both the ITA1 open wire and SG2 open wire for continuity. This involves checking that there is less than 1 ohm of resistance when the wiring is intact. If either wiring exhibits an open circuit or excessive resistance, this indicates a fault in the wiring that could be causing the high voltage condition detected by the PCM. Repairing or replacing faulty wiring is essential for restoring proper sensor function and addressing the DTC P0113 effectively. During this step, if the previous tests return normal results, the focus shifts to inspecting the PCM, the powertrain control module responsible for processing input from various sensors, including the IAT sensor. The technician should evaluate the circuit integrity and verify that the PCM is receiving accurate data without interference. In some instances, PCM faults can stem from software issues or electrical malfunctions. If it's determined that the other components tested in prior steps are functioning correctly, it concludes that the PCM may be at fault. Addressing any PCM issues usually involves either reprogramming or replacing the module to ensure it correctly interprets sensor signals and orchestrates optimal engine functionality. Once all necessary repairs have been made, it's imperative to clear the diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS. After the codes have been cleared, the technician should conduct a test drive of the vehicle to ensure that the issue has been resolved. During the test drive, monitoring data from the IAT sensor, as well as engine performance, is critical to confirm that normal functionality is restored. If the check engine light does not reappear and the vehicle operates smoothly with no signs of rough performance or poor fuel economy, it indicates successful repair. Final verification ensures the reliability of the repair and confirms that the vehicle meets operational standards before returning it to the customer. Engaging in preventive maintenance can significantly diminish the likelihood of encountering DTC P0113 and related issues. Regular inspections and checks of the IAT sensor and NAF sensor are essential, as they tend to experience wear and tear over time. Ensuring that wiring and connections are intact will minimize the risk of faults that can lead to high voltage conditions. Keeping the air intake system clean can also enhance sensor performance, contributing to optimal engine function. Scheduling routine maintenance checks allows technicians to identify potential issues before they escalate, ensuring better vehicle reliability and performance. Establishing a proactive maintenance schedule is a best practice for any vehicle owner. In summary, understanding the role of the intake air temperature IAT sensor and its connection to the vehicle's performance is crucial in resolving the DTC P0113. Effective troubleshooting follows a systematic approach that includes testing the sensor, inspecting wiring, and verifying the PCM's function. If any irregularities are identified, prompt and appropriate repairs can restore optimal functioning. Regular vehicle maintenance plays a vital role in preventing issues related to the IAT sensor and ensuring reliable engine performance. By adhering to these guidelines, vehicle owners can enjoy efficient operation and avoid the stress of unexpected engine performance problems. Please like and subscribe to the channel. See you next time.